One example of an application of an exponential function is radioactive decay. The amount of cesium-137 remaining from 1 kilogram after t years is given by the exponential function c of t equals 2 to the negative t over 30. How much is left after 5 years? To find this, we plug in 5 for t. C of 5 equals 2 to the negative 5 over 30. You can plug in from here or reduce this to 2 to the negative 1 over 6. To find this, you really do need to plug into a calculator. This will not be a nice number. This result is 0.89 kilograms. So after 5 years, 0.89 kilograms remain of the 1 kilogram that was begun with. After 10 years, that means plugging in 10 for t. That would be c of t, which is 2 to the negative 10 over 30, which is 2 to the negative 1/3 if we reduce that. Again, we need to plug into a calculator to compute this. It is 0.79 kilograms. So we can see that less remains after 10 years. The amount is decaying or decreasing exponentially. So when will the amount have decreased by half? That means when will we have 0.5 kilograms remaining? So when will the result of that function be 0.5? So if we think about it, half or 0.5 is equal to 2 to the negative 1. So really this question is asking, when will the exponent of this function be negative 1? So when will negative t over 30 be equal to negative 1? You might be able to see already that that would be when this fraction is equal to 1, t over 30. So that means t needs to be 30. Or you could solve for t by multiplying by 30 on both sides to get negative t equals negative 30. Then divide by negative 1 to get that t is equal to 30 years. So that amount is called the half-life of this element. So it will take 30 years for cesium-137 to decrease by half. Another example of an application of exponential functions is gross domestic product. The gross domestic product, or GDP, in trillions of dollars for a country is given by f of x equals 0.004 times 1.09 to the x, where x is the number of years after 2000. Find the GDP in 2010. Since x is the number of years after 2000, GDP 2010 corresponds to the year x equals 10. So to find the GDP in 2010, we find f of 10, which would be 0.004 times 1.09 to the 10, which is 0.0095, and this is in trillions of dollars. To find the GDP in 2050, that corresponds to x equals 50. So we find f of 50, which would be 0.004 times 1.09 to the 50, which is 0.2974 trillion dollars. So we can see that the amount grows with time. Another example of exponential decay is credit cards. Suppose that you owe $500 on a credit card. If you make no new purchases and if you pay off the minimum amount of 2% each month with an interest rate of 1%, the balance on your card is modeled by the function b of t equals 500 times 0.9898 to the t, where t is the time in months. First, let's find the balance after 2 months. So that means plug in 2 for t, so b of 2, which would be 500 times 0.9898 to the 2, which results in 489.85. So after 2 months, very little of the balance has been paid off, about $10. Find the balance after 5 years. So since our time is measured in months, we need to convert 5 years to months. So since there are 12 months in a year, the number of months would be 5 times 12, which is 60. So 60 is the t-value that we plug in. So we find b of 60, which is equal to 500 times 0.9898 to the 60th power. And this result is 270.28. So the balance on the card is about half after 5 years with this interest rate information.